In this video, we will be discussing the dynamic feedback control system that keeps every computer cool. Every computer, from the ones built in the 90s to the ones protecting our country, need a controllable fan to stay cool.
So we got our information from fan-cooled enclosure analysis. This is the first volume done by Gordon and Ellison. So, pretty much what you have going on is the CPU components are heating up because they're running stuff like MATLAB. And so that is measured by some kind of temperature probe. Alright, and now that goes into our control. So that makes our inputs as a temperature, and as it always should be in degrees Celsius. Then that goes into the fan. And what goes into the fan is the RPMs, omega. But how does it come up with this omega value? So, going back to some fun chemistry, Q dot equals M dot Cp delta T. Alright? So it knows what temperature it wants to be at and what temperature it's at. And to make things easier, we're going to take M dot to get out to density times the volumetric flow rate, which is denoted by G. And so if we solve this whole thing out for, we get G equals Q dot rho Cp delta T. And if we hold both the diameter of the fan and the density of the air constant, we can just keep them as a ratio of the initial omega and where it needs to be with the volumetric airflow to begin with to what the volumetric airflow needs to be. So simply put, omega 2 is G2 over G1 times omega 1. So in this control system we have actually just a P control. It's just a gain. And with the metrics that we really want to know are just the peak response, because we want to get as cool as fast as possible, because if it stays too warm for too long, then we use control. And this is a continuous function because you always want your computer to be cold as long as possible.
As was discussed and shown earlier, here is a block diagram showing all the different parts of the system. Note the input is the temperature and output is the angular velocity going to the fan. Using one of our own computers, we plotted the temperature of the computer as well as the fan angular velocity as time progressed. Notice that as the temperature of the computer increases, as does the angular velocity of the fan, demonstrating the feedback control system the computer is using to make sure the computer stays cool. Shown are some general characteristics about the system and how it is controlled. Thanks for watching.